It's on dark mode. Let's see. Okay, how do I change the mode? No idea. Is this too contrasting, or it's better to go with light default? Those lights become too dark. Is it better that you want to see with these lights off and then no contrast, or high contrast and lights on? Looks fine. Okay. We can change it later if needed. Oh, this didn't change. Okay. Okay, so this is IDS 594. ML deployment, MLOps, there's so many names going around. Not just ML, there's LLM ops now, AI ops and stuff like that. But this is IDS 594, the 2-credit course. So I hope everybody's here for this this course and not something else. There's another course with the same IDS 594, but it's something else, cybersecurity, I think. So if you're in that course, then you should go to that one. If not, we're good. What we'll do today is pretty lightweight. And in fact, I'll tell you when I go through the syllabus that the course is actually very hands-on. So there'll be less lecturing and more try something out, let's see what works. And we'll talk about what exactly we're trying to do, but it's a little bit more lab style approach. Okay, it's a little bit more informal approach. So what I'll do is, as usual with many courses, I'm going to go through the syllabus just to get you set in terms of what we're trying to do here and what the expectation is, and some details about the schedule. And then we'll get into what we plan to do today. Today is actually pretty lightweight, mostly some setting up stuff. Yeah, so we'll get started. Okay, actually, this view is like an update from GitHub, I guess. We're going to change the view soon, but I don't like all the extra stuff that's being shown around, but why are things selected? Okay. Use with the mouse. Okay, so what we'll do, so I'm just showing it from here. What I'm going to do for the majority of the course is actually I'll have a clone of this repository, and what I'll share is a Jupyter and a notebook, and we'll do stuff there. But I thought let me not get into that right now. So meeting time 6:30 to 9 on Thursdays, and office hours the same day from 2 to 3. And if you want a separate Zoom appointment or something, you can do that as well. Okay. So what's the objective of this course? I mean, this was a new course some time ago, but now it's, I guess, we should improve on it. But with the hope that maybe in the future it's going to be a 4-credit course, because operations part of machine learning is something that is kind of missing in many of the analytics programs. It's kind of useful for people who want to know these things. You don't have to be the person doing these types of deployment activities themselves, but at least you should know what the rest of the teams are doing so that you can optimize for it and you can actually plan for it. Let's say you're a business analyst or a product owner or something like that, or even an analyst, right? Or even a data scientist. You would like to know how things are going to production, how will they be maintained. Much of the classes that you've done before, maybe 572, 575, or 576, or even none, as long as you have some basic idea about machine learning, much of it you will see from maybe Kaggle or elsewhere is like you get a bunch of data, download it someplace, maybe typically on your laptop or maybe somewhere else, maybe in a S3 bucket somewhere. You run some analysis. It could be exploratory analysis, or you build a prediction model by using compute from your own laptop or from elsewhere, and you get a model. Okay, and the model, sometimes you save it as a pickle file, and then you do some extra stuff like model diagnostics, and that's where it stops. At least in courses in the universities, but that's not where businesses stop, right? I mean, clearly, everything that we see today, I know. I mean, at least I don't know about you guys, but I use my phone a lot. And every app that I use has some machine learning in there, right? Whether it's recommendations, whether it's predictions like weather forecasting or something else, right? Everything has some machine learning model constantly running behind the scenes. So previously, maybe 20 years ago, when ML was like not that mainstream, perhaps, maybe it was database lookups. Like a database was huge, databases were huge, and you look up things, fast retrieval, and so on. So now, instead of retrieval, in addition to retrieval, we care about models being constantly online and constantly being monitored, constantly being tested that they're not completely, going off the rails, things like that, right? So, so that's the context of this course. So you just need to know basics of machine learning or some familiarity with machine learning. You don't need to know how a model works and how what its performance is itself. Like that's not the main prerequisite for this course, but you need to know that ML is like one type of software that you would like to be deployed, and we'll talk about many of what do we mean by deployed in this course. Is a software that needs to be constantly running, constantly, has to be reliable and has to be secure, and many such things. And if that's the case, then how are people doing it? How is OpenAI setting up, such giant model, whatever the model is, GPT-4 or GPT-3? How is it doing it? And how is it? What compute is it using? How is it making it available to people? And so on. Right? So not just OpenAI, but like Microsoft's and Google's, and not just those big companies, but even many tech companies and non-tech companies are leveraging machine learning, not just language models, but many other things. And they have teams, and they're all learning now in the past decade or 5 years, or even today, if you join any of these companies, they're all learning and they're trying to mature their ways and processes of getting things to run beyond a data scientist or analyst or a researcher's laptop, or some ad hoc script to something which is more professional looking and also serve some professional criteria. Okay, so what we're going to do is just complementing the actual model building and the actual domain understanding and actual domain related details about the ML model. Okay. That's the focus, although there's huge overlap with software engineering subfield called, I guess, DevOps. But we're not really going to conquer much of DevOps at all, and neither will we kind of be a complete treatment of machine learning deployment. This is just I would say, a very basic introduction to getting more familiar with your computers. That's all I'll say. Basic introduction to some tools and techniques that kind of give you some ideas. Okay, and once you get the sense of how this is how it's done, you can pick the state-of-the-art tool and state-of-the-art process to kind of and not be, I guess, overwhelmed. Okay, and so, for example, one of the things that we'll try to see today, and maybe even next lecture, or maybe it's going to be quick. So maybe this lecture is using a web app framework called Flask, which is a Python package essentially, to continuously run and serve an ML model. Okay, what's special about an ML model? There's nothing, right? It's a function which takes some input, like generally a feature vector, and produces a prediction, right? So it's just a function which takes some input and responds to some number or a class or whatever. So that's just a function. So there's nothing special about deploying an ML model versus running a Flask app with anything else, like some other function which would go retrieve a row in a database and report back some annual sales of some company in some geography, right? It's not too different. So you'll see that there's going to be overlaps like that. But we'll pick some tools. Flask is the simplest web tool or web app building tool in Python. But there are others, right? Django is another older technology, but now you have many other ones like what is it called, Fast API and things like that. I don't know if you have heard of these names, but if you're not heard of it, don't worry. But all I'm saying is we'll pick some tools to illustrate, okay, this is how a basic software can be deployed and kept running somewhere, so that end users could be a team next to adjacent to you guys in your companies, or it could be actually consumers, like how OpenAI does it, can use it, okay, reliably. So there's a bunch of topics here. Some of you may be familiar with them through your internships or prior work experiences, and some of you probably not. And so there's a huge heterogeneity. And so that means that much of the balance will be a little bit tilted towards basics. Okay, not just a little bit, like quite a bit. So it may seem basic, but it's just if you see something basic and that 15 minutes or so, you can actually explore more complex things in that time. So that's what the course is about. The course is about everything about the machine learning model lifecycle. Okay, lifecycle. I guess there's actually a Wikipedia article, I think in the slides. I have a link to it. But we'll look at managing models. Okay, it's not just one model, right? There could be just for recommendations. Let's say think of Netflix, right? Just for recommendations, there'll be hundreds, in fact, thousands of models per geography, per demographic. They could make all of that into features, but generally what they'll do is, depending on, for example, the tenure of the subscriber, there's somebody who just joined Netflix, they probably, you want to expose more, new stuff, so that you can figure out their pattern versus somebody who's a more loyal customer from some years ago, right? So there's going to be many models, and how do you manage models? Monitoring models, which is that models should not stop, should not stop being relevant. Okay, so sometimes, especially models which do recommendations, if the trends pass, like cultural trends pass, then if you have not taken that into account, suddenly they're recommending irrelevant things. Okay? We'll kind of mix couple of topics like A/B testing, which is testing for us. In our case, it will be testing model 1 versus model 2, rather than 2 ways to do anything else. Okay, and also in that journey, and this is going to be a very, I would say, idiosyncratic journey, pretty much a random walk, because we can't cover everything, right? So it's like a 2-credit course, but we'll cover a few tidbits here and there. And so in that journey, we'll look at version control, and as you can see, this course repository is version control. We'll look at some general software engineering ideas like containerization. How is it different from just running what is called a virtual machine? And if time, depending on time and so on, we can see some other ideas. Okay, so that's the general context. So to summarize, this is just complementing, as in parallel to all the 572, 575, 576, and many other numbers there. Everything else which focuses on modeling itself is just trying to say, how do these models actually, go into production, as in actually be used by people. Okay, and that requires some software engineering, some guarantees, like, okay, it's scalable. If 10 people suddenly ask for predictions, it should not like take 10 times more time to kind of give the answers. Scalability, reliability, updating, management of multiple models, maybe multiple versions of it because they were retrained. So all that stuff is what we want to kind of at least get a sense of. And we'll do that through the simplest example tools. And so in that sense, also we are not a little bit incomplete, but the hope is that at the end of this course, at the end of 8 weeks, you realize that, okay, there's this whole big world. It's not exactly DevOps. DevOps is a much bigger world of software engineering, because it's a much older, much more mature area. But MLOps is a growing area with lots of new big companies now. Okay. That's the summary. Any questions here, like what to expect? So in terms of expectations, as I said, the mode of the course is really lab. So lab focused in the sense that you can use your laptops in the class, obviously, to kind of explore and try out things that are discussed in the class. So the first maybe 1/3 of the class is actually supposed to be, I mean, at least on paper is supposed to be the lecture content. And then the 2/3 are really trying out whatever we discussed. Okay. And there's going to be challenges for sure. So given the heterogeneity, so we'll address that. Okay, so any questions here in terms of what to expect and what the content is about? It's really, we don't really care about the actual model. It could be a linear regression model, which doesn't require much of this stuff, but that's the focus. Okay, so if you're going to want to learn machine learning here, there's no machine learning here beyond obviously using them to kind of do other things. Okay. Okay, and also this is a course where please just like my other courses, you can always ask questions anytime. Don't be afraid. And obviously, if some of you are already very savvy with especially we're going to use Linux or whatever variations, but if you're already savvy with Linux, so you can also help your I guess other students around to get up to speed. Okay, so let's see. So as you can see, the schedule is quite short. There's only a few lectures, and there is a couple of slots for projects. So this is actually a project-based class. When I said it's a lab-based class, so lecture sessions are mostly you should try things out. And the idea of this course is, ideal situation, you should be identifying some tool that you would like to explore in the first couple of lectures, and then over the next 4 to 6 weeks, you kind of try that tool, try to understand what is it, from the business context back to all the way to what exactly the tool does, how does it do it, and some use cases or whatever tutorial examples that you could see online, or you could do something yourself creatively. So that's the goal. So it's a project-focused course. What you learn is probably in the last couple of lectures where all groups, and you'll see, I'll tell you about the groups, but all groups are going to present something that they explored, some tool or some strategy or something to do with ML deployment and management. And that's where you get most bang for buck, because they'll explore a variety of tools and they're more up to date than what I'm going to talk about. So in my lectures, it's going to be very basic stuff, a little bit older technology, older in the sense that a few years old perhaps, but what you'll see in your project's presentations will be your peers will present something which is more recent, like in 2023 or something that released in 2022 and so on. Okay, so I'll not go through the chapters now because I have a slide deck where there's some information. But the topics here kind of tell you what the learning goals are. I mean, these topics will not be able to cover all of them because the number of lecture slots is less than the number of topics here, but we'll try to cover a few of them. So today actually corresponds to chapter 1. So we'll try to do some of these things. I'll come back to these goals in a second, but let me come to some of the other logistics. Okay. Firstly, course materials. Actually, I didn't write it explicitly in this page, syllabus page, but the source of truth is actually the documentation of the tools that we use. Okay, because those tools evolve with versions and their stable documentation, just like scikit-learn, right? If you look at scikit-learn version 0.12 versus 0.19 or whatever, they're going to be very different, right? So whatever is the latest stable version of the tools that we'll see are the actual things that we should be referring to. Okay, everything else gets stale, may have inaccuracies and so on. Okay, so that's the source of truth. So if you come across a tool name like Flask, for example, go to Flask's documentation. And I'll also probably do that if needed. But in addition to that, there's a slide deck, which is a very handy quick map of like what sub-selection of topics that we'll look at in this course. Okay. But those are not the only tools that define MLOps or ML deployment. There are many tools. It's just that we're not able to cover not just tools, but also ideas, key ideas, not just implementation details, not software specific, but general patterns of how to do things. There are more, but we will look at a few. So that slide deck is open, but I'll open it in a second. And the second resource, which is just a collection of I would say code examples for each of the chapters here, but also like what we discussed. So in the class, I'm essentially gonna start the code example and kind of describe and maybe we'll run it and see how it works. Okay. So let's actually talk about the project component, which is, as I said, the key component of this course. So this is really your opportunity to explore something that you want to explore. Okay, it could be, hey, I've been using Matplotlib or Plotly or whatever, but how do I actually make it into an app like Tableau? Obviously not as feature rich as Tableau, but something that people can interact with. Like, how do you go from there to there? There are actually tools, okay, many tools in fact. So that that could be a motivation for like doing something, especially if you're into visualization, like what types of tools give me rich visualization versus static image, right? I can always obviously display a static image as a PNG or whatever JPEG and just put it in an HTML file and put it in the URL. Obviously you can do that, but like what would I do for visualization, or what would I like how would I monitor that the data has changed from last batch of data from last month to this month? You look at distributions, right? So how do I do that computation, and how do I schedule that computation every time new data comes in? Those are things that lead to some projects. Okay, so scheduling means there should be some scheduling software. Fetching data means there has to be some script to kind of get, oh, data changed, date of the data changed, and get it. So there are all these extra tooling that is needed to kind of execute the type of business problems we'll see. Okay, so there is a lot of there are some examples of, I think there are some examples on an Excel sheet. And what Excel sheet do I mean? I think in the so there's like Excel, sorry, a spreadsheet, actually a Google sheet that's available. That's a link on the Blackboard site. So I hope everybody has access to Blackboard already. So one of the links on the top left is going to be this spreadsheet. And on the spreadsheet, there's actually a tab which shows some example tools. So if you want some project ideas, there's a bunch of tools there that you can explore. Okay, just to give a sense of like what you want to do. I'm not going to show it right now, but there are some tools. So grading, as I said, it's actually a self-directed course, essentially, informally. So there are no graded assignments. In fact, in the sense that that project is your culmination of what you learn for the tool you explore, while in the lectures you learn some of the other ideas, okay? Because you cannot really go in depth with all the ideas at the same time in a short course. So the project is 90% of the grade and is split, and it says some criteria of, the criteria is actually very generic, not specific to the project, what tool or anything. It's just saying you need to be clear in terms of documenting what does the tool does, what did you do, what is your impression of what it can be used for, and so on. Okay. And so some information like that is already documented in the project page. You can look at it. And there's some code, some necessary component for class participation. Okay, this is because in the class you should not be, first of all you should come, and obviously you should be also trying to work out some of these things, because it's kind of useful to kind of get familiar with some of these ideas, okay, which complement. Maybe if you want to be a data scientist, that's fine, but you want to know some of these other things. Okay. Okay, so any questions? Obviously, there's some, if you have some constraints or accommodations that you need, read this part. This is very concise, but there are links. And obviously, other courses will also have mentioned this. So try to figure this out. And if you need it, obviously contact the instructor or the appropriate resources in the department or in the university. Okay. Any questions about the walkthrough? I mean, this is just a very generic mission. You could have done it yourself, but I wanted to give you a little bit more context commentary on what is the expectation. Okay, you're not software engineers. Okay, that's at least this course is not about software engineering. If you want to do software engineering, this is going to be a good fun course to kind of just know about it, but it's not going to be at your level at all. It's just an introduction with a few, as I said, example tools to get a feel for how ML is managed. Okay. Any questions otherwise? No? Yeah.
Plus the course. So is it really code heavy course?
No, it's coding as in what? It's not a code heavy course. So if you oh, it's a submission of if you have code for your project. This one. It's one day before your presentations. If you have code, then you should obviously. I mean, if you've tried a tool, generally you will write something to interact with the tool. I mean, whether obviously it's a UI tool, then obviously you interact with the mouse and whatever. You'll have screenshots or perhaps or something like that. But generally most of the tools you'll see is there will be some way to interact with it. Like even think of pandas, right? So pandas is a tool that you might have used for processing tabular data. So that would, I mean, I would say pandas is now so mainstream that that may not be a good choice for a project. But if that was a tool, then you would have to, hey, this is how I create a data frame, and this is how I would do slicing and dicing, and this is how it compares with. There are some other solutions now, which are which claim to be like better in terms of like memory management or lazy evaluation or whatever it is. So you should be able to kind of explore those things. Okay. But that may involve some code writing, which is just trying out the tool. Yeah. Yeah. So code itself is not, it's not like a requirement. It just depends on which tool you pick. Yeah. Anything else? Okay. Good. So let's actually then come back to today's learning goals. I mean, I'll actually, instead of looking at today's learning goals, let me go to the slides first, and then I'll come back to learning goals for today. Today is a little bit different, a little bit heavier on the lecturing part, because I want to kind of set the expectations and where you're going for the next 8 weeks or so. So, okay, so I think everybody has access to this. This is just linked on the syllabus page. So I will not repeat what I just said because it's still an evolving term with companies creating new words like AI ops and LLM ops, for example, depending on like what's in vogue. But all of them are all about like managing machine learning artifacts. Okay. And you can, I mean, in this diagram, they're just saying that machine learning, DevOps, and data engineering, the intersection of those three is called MLOps. So what is DevOps? Like, which I'm not qualified to probably even, I guess, define. But it's everything that software engineers do, infrastructure engineers do, to kind of so that software written by software engineers can actually be served for whatever purpose it is to clients or end users or other software, right? And data engineering is basically working with, trying to get data in the right formats, in the right place, with the right fidelity, quality, and control, and all that at scale, and many different properties that you want, so that users like data scientists, like whatever business analysts, whoever it is who consumes data, can consume it with a lot more rigor and control than just download a CSV and do something, right? Yeah. So this is actually kind of reflects what those charter lists were in that diagram, so in that syllabus page. But I wanted to quickly mention these as these are the specific topics that we look at, and then I'll come back to the goals for today. Today's goal, as you saw, it was just setting up a Jupyter environment, which something many of you have already done, perhaps, but we'll redo it again. Okay. So the course is actually like these 6, I guess, categories, but the 6 categories mostly just tools for general tools to become a better programmer. Okay, you're already through this program. You already have spent a ton of time in Python, maybe even R, and maybe even other languages. But how to become a better programmer may have some extra tricks that you want to learn. But the first 4 are categorized as this. So batch, ML models, and inference is really focused on the word batch just means that we don't really we really think of a batch of data coming in, training once, getting a model, and then not worrying about retraining for a week or a month again. So we have a a snapshot of a model that we train, and we don't worry about. I mean, we retrain it, but after some periodic interval, after a period of time. Okay, so that's all I mean by batch here. And so we have an artifact, a model artifact at any given point of time, and we just want to expose it to the users who want to consume it, right? So it could be some downstream services which consume that and map it back to some movie names for Netflix, or it could be directly being exposed to users by predicting, what's the weather tomorrow and so on. Okay. So there are many ways to do it. Even just this, just to achieve this, like you have a snapshot of a model and you want to expose it to users. Just there are many ways that these MLOps folks or at least companies try to do it. Okay? And it could be, I mean, here I've written three different ends of that spectrum. One end is, I just wrote it as web service, which just means that on one end of the spectrum, they will do a lot of hard work in custom or do a lot of hard work in spinning up their own machines from which they will serve the model so that people can query it for predictions. In between is this container idea. So sorry, the third bullet point that you see, where they will not care about the spinning up machines from the ground up and taking care of everything about the machine, because every machine, whether it's a laptop or a machine which is a server sitting in somebody else's data center, they all need extra things to be taken care of in addition to your model, right? They need to care about their security of the operating system, other things which are unrelated to you. In the first bullet point, web servers, I just mean that there are people who will kind of spin up everything. Okay? They'll take care of everything in your company, right? Compared to containers, where you just need to, people will only care about your program and associated supporting software. Okay, and we'll see that a couple of lectures later how we containerize, our models. And don't care about the actual machine, whether it's a 100 GB RAM machine or whether it's a 50 GB RAM machine. We're not concerned too much about that. And then the extreme end of the spectrum is the serverless services, a serverless approach where you only care about your program. Obviously, some aspects of dependency, but you don't care about anything else at all. Okay, so you might have heard of this popular technology called Lambda, AWS Lambda by Amazon. It's a technology where you pretty much are concerned with your function, your specific activity that you want to do, and you don't care about where it runs, and all the details that are related to that. Okay. So those are three, I guess, types of, you can deploy a batch model or basically a snapshot of a machine learning model, and each one has its effort versus ease versus cost versus many different considerations that teams and whatever managers and VPs do. But those are three examples that we'll see in this course. Okay, in a spread over like 2 or 3 lectures, basically. Sorry. And the next bucket, I'll not get into too much detail now, but I just want to explain. The second one is about managing the models. Okay, so deploying models is one aspect. So you deployed a model and it's ready to, people are consuming it. It's fail safe. Maybe you have like multiple replicas and so on, whatever. So we'll see all that ideas later. The second bucket is about just scheduling things. Like remember, if it's a batch model, maybe it became stale next month. You want to replace it with something else. Okay, you swap out with something else, or you collected a new batch of data. Somebody told you, hey, there's new data available. You start with the old model, incrementally update its parameters or weights so that your model is now trained with freshest batch of data in addition to historical data. So you need to schedule things. Okay, and your current your current laptop, for example, has a lot of services already scheduled behind the scenes, especially if you're running a Mac or a Linux. You can actually see what processes have been scheduled to run and what times. Okay, like if you are using a backup solution, then it has some scheduled approach to kind of backup. Even Time Machine, Time Machine probably is not scheduled, but things like that. So scheduling is one aspect, and we'll see some scheduling approaches that every operating system comes with, like cron, for example, is the name of the utility, versus scheduling across machines. Okay, that's, there are software, not just for machine learning, but for in general, which can schedule across machines. Okay, and one machine versus multiple machines is the big delta in computing. Okay, in one machine, everything is available and everything is close by, and it's the nice situation to be in. And the moment you go to multiple machines, things are complicated. I think if your folks are doing big data and you will do it as a part of your program, you're literally looking at multiple machine systems, right? It's Spark, for example, and Hadoop and so on, which is actually the next data point, but it's more complicated. So anyway, scheduling is one aspect. Versioning is that, as I said, models, obviously one snapshot versus the other snapshot, you can version tag it as, okay, a model from August 2023 versus a model from September 2023. That's not enough. Every time you train a model, you want automatic logging of, okay, what were the hyperparameters, what was the data, how did it learn, what was the training curve, and all that you can log it. Okay, either you can do it yourself, or there are actually utilities that help you do it. In fact, there's a multi-billion-dollar company called Weights and Biases. I don't know if you've heard of it, or try to apply to that company. But it's kind of focuses on that aspect, which is version. Not just that, but it does more things. So that's an aspect that we look into. And lastly, the last one is A/B testing, which is not just specific to machine learning, but also still is relevant to machine learning. For example, Netflix's recommendation system. What if the team improves, comes up with a new recommendation model? How do they kind of evaluate, right? So obviously offline metrics, like what do you call NDCG, and I don't know if you know about recommendation system metrics, but let's say classification metrics, like ROC curve, AUC values, or whatever they are, right? So those numbers, may differentiate to model 1 versus model 2 offline, but we don't know how they'll actually do when humans are involved or when actually it's in production. Okay, especially it makes sense for recommendations because humans are the ones who will consume it and then give feedback on whether it's actually making them stay longer on your app or whatever service and so on, right? That's just an example, but A/B testing is an important component, and it has its connections to statistics, right? A/B testing is nothing but two-sample hypothesis test, which is something that in 570 or maybe even other courses you have looked at. But that's how do you instrument A/B tests? How do you instrument the infrastructure to kind of, when a user comes in to your service, how do you bucket them into part A versus part B? It's actually very simple. You have to flip a coin, random.rand, you can call it, and check whether the value is less than 0.5 or greater than 0.5, and then bucket them, for example. But there are software, many companies which do that in a high quality way, okay, so that biases are not introduced and the A/B test results are actually correct and so on, right? That's the second bucket. Third bucket is actually pretty much big data. Just a quick exposure to big data. I mean, we have that course, full course, but we can look at how does Spark scale up, or how does there are other packages and other solutions, like Dask actually is a Dask is a kind of pretty much a replacement for pandas. So even on a single machine, if you use Dask instead of pandas, instead of loading all your data into memory, Dask does it in a lazy way, so that if your CSV file, let's say, is like more than your memory size of your laptop, you can actually use Dask in case at some point you're just reducing the data. Then Dask can take care of that somewhat for you. I mean, it's not a full standard replacement, but it can help you. Same thing with pandas. If you run some computation, let's say apply operation or something like that, it'll just use one core of your machine. And generally, most machines today have multiple cores. So if you want to use multiple cores and you're just doing an apply operation, then Dask, for example, you can partition your data so that multiple cores can be used, and on each core you're applying, you're running compute. So you're actually being more efficient. Okay? Last bucket is just to contrast with the first bucket, which is streaming and real-time inference. Okay, so streaming is just a paradigm where you don't think of data at rest. Okay, in batch setting, data is resting somewhere, maybe in a DB or anywhere, and then you fetch it, train your model, get an artifact of the model. Okay? So here, the focus is not so much about what is at rest. It's more about multiple entities interacting with each other, multiple entities as in multiple softwares. It could be the DB interacting. Let's say your program needs some data from the DB. Your program can fetch data from the DB, not directly, through some intermediate software, and do its processing at its own speed. Maybe it's a different language and different machine, different latency. And then its downstream computations are again sent back to some intermediate software so that some other person, some other software can consume it at its own pace. So there's this whole notion of producers and consumers. Producers produce data, consumers consume data, and they don't have to kind of work in sync. Okay, so it's a different view of the system, because generally in the system it's not just one software, right? It's going to be multiple softwares which are all doing different things. Like, as I said, some software fetching data, some software training, some software checking the model health. All of them will be working at their own cadence, and they all need some information from each other. And they could all be written in different softwares. One could be in Java, one could be in Python. They all could be in different machines. How do they all work together? That's a streaming paradigm where it's essentially, at the end of the day, it's just some parallelization idea, but it's a way to decouple things. Okay? Things are decoupled. So the speed at which you make predictions has nothing to do with the speed at which something else computes, maybe downstream, some decision-making tool, for example. So it's basically that. And there are many tools there. We look at one called Apache Kafka, but it's just to give a flavor of what this is. Okay. And as I said, there are many tools. VS Code, many of you probably already use it, but not just VS Code, but there are many IDEs for different programming languages. But there are also many tools for what I've been saying is like a little bit modern Python, Poetry or MyPy and Flake. We'll see if we have time, but these are additional tools to kind of improve your code quality and make your code better. Okay, better than if without these tools, it'll be a little bit more. It'll take more time for you to get to the same goal. Okay. Any questions here? This is just specific tools now, I think. But this part might be a little bit hard because each of the tools requires its own kind of lecture or treatment. Any questions here? Okay, then let's get started with the first lecture content, which is actually just the first bullet point, web servers. Okay, so actually let me quickly mention what the goals for today are. We may not cover everything, but I wanted to just say what the goals are. We'll set up a Python environment and we'll create a Jupyter session. I mean, I'll do it and you can also do it on your machines. You can actually connect to Jupyter using SSH. You don't need SSH is again a way to securely connect to remote machines, and I'll discuss that in that context. I don't think we'll get a chance to really secure a web server, but we will. We'll spin up a web server. We'll talk about what makes it a server. How are we going to talk to it? There's some basic things that are not resolved. I mean, you may have some idea already, but it's better to kind of revisit and cleanly state like what exactly is happening here. And then in particular, we'll use Flask to serve a machine learning model. It seems, after all this effort, it seems like a very simple thing to do, but it's good to know the basics so that it's the same idea behind OpenAI, and ChatGPT interface, right? It's the same ideas, but at scale. Okay. Okay, so actually, let me go to that section and just show this slide, these two slides. Okay, so yeah, so as I said, you can deploy ML models, and these are you already created it. Some data scientists already created it by downloading some data on some compute resource and computing and getting a model. Okay, somehow they've gotten it. It could be a simple linear regression model. In fact, that's what we'll see in a simple demo. But once you have it, you want to serve it, right? And so you need a program that serves it, and that program should sit on a machine, which let's call it a server, right? And that machine can be anything. It can be like EC2 stands for, I guess, I don't know, some compute. So EC2 is a specific name for compute resources, like a virtual machine that you can rent from Amazon. Similarly, Google Cloud has their own instances that you can rent. There's just virtual machines. Okay? And we'll talk about virtual machines maybe after I discuss this. But virtual machines are just virtualized full running systems. Okay, fully running systems, fully running operating systems. Okay, like you can run a Windows inside a Windows machine. Like if you have a Windows machine, you can actually run a virtualized Windows instance, which has nothing to do with the, or your current Windows instance. Okay. Similarly, you can run a Linux instance within your Windows machine as well, right? So the way they run it is through virtualization. And that's how. So when Amazon, for example, this cloud provider rents you machines, typically, unless you explicitly ask for what is called a bare metal machine, they will generally give you a virtual machine. Okay? Because on their side, on your side, they decouple your requirement to what hardware they have. For example, their hardware may have 128 gigs of RAM. You only want 16 gigs of RAM. They can actually create a virtual machine on that 128 gig machine, which only allocates 16 gigs for you and maybe 16 gigs for somebody else, right? And so generally, any remotely managed machine would be a server, something which is not right next to you. You as in the client here. So the end users of your ML product or ML artifact, your model, they will interact with server. They can interact with servers in various ways. Okay, let's call them client, the people who interact with your server, and they can interact with your program, with your prediction model, which is residing on the server, running on the server in various ways. Here, I'm just showing you one way. I guess that's where the word web comes from. We are going to use the HTTP verbs, or the HTTP protocol, hypertext, I guess, transfer protocol, to interact with the server. You can interact with servers in many different ways. If two programs can interact with each other in many different ways. Obviously, there's a way in which the network, behind the scenes will, facilitate that. But we're going to look at just the one of the ways, which is HTTP. So on the client side, there are many programs actually. For example, Macs and Linux machines, come with a program called curl. If not, you can install it. Obviously, Windows has different programs, but if you are on Windows and if you are in Windows subsystem for Linux, then you can also use curl. Curl is a way to, from the command line, go to URL and fetch whatever the URL is, giving you information. Right? Every web page that you open on your browser, when you click, when you type a, whatever URL, like how we did here, right? This URL here. That's our client, our browser client, which has asked for a resource at this location. And the way we ask it is generally what is called a GET request or a POST request. GET request is like, hey, give me some resource. POST is like, here's some information that you can store. And there's some other extra verbs. I mean, I'll not get into the details of verbs, but that's how you interact. And response from the server can be text, for example, or it could be what is called a JavaScript object notation, I guess JSON, which is essentially looks like a dictionary, Python dictionary, with keys and values and so on. It could be many different ways. It could be also encrypted. It could be in byte, without explicitly. You may have to encode and decode it, for example. Sorry, you may have to decode it. So in many ways, the server can respond. In fact, here the server responded with a lot of text, actually, JavaScript, CSS, and HTML, and a lot of things, and all that was put together back into some nice way in which we are getting rendered this page with the slide type of notation and everything, right? So behind the scenes is all text, right? So that's how the interaction works. And what we want to do today is just get to, obviously set up Python and Jupyter, and then maybe just try out this with Flask. Okay, and we'll see in Flask how exactly, Flask and Fast API and all of them work very similarly. Maybe more work is needed for other things like Django and so on, which are also web frameworks. The three names that I mentioned, Flask, Fast API, and Django, are just web frameworks. But Fast API and Flask work similarly, and we'll see how Flask maps a request to a function so that we can actually get better response prediction. It's very basic, but worth looking into as a quick example. Yeah, let's look at the tool names before we get into some trial. So if you want to try out virtual machines and you don't want to care about like cloud providers, at least for this lecture, we'll try out some cloud services later. Maybe you want to try, if you want to try them, you will have to use the cloud providers. But for today, if you already have a Linux machine, you don't need all this. But if you don't, then okay. If you don't, then you can install VirtualBox. It's a free software with which you can install any virtual machine, any type of virtual machine, as long as you have, a license or something for that to run that operating system. Okay? Generally, for Windows, you might need a license, but for most of the Linux distributions, you can just download the kind of the CD or the ISO file, and you can get a virtualized operating system of that Linux flavor. Okay, like Ubuntu, for example, is a very popular flavor. You can just run it. Okay, so it's a program. Well, I should not use the mouse because it's just making it smaller. Yeah, and then you can also use EC2. So I don't know how many. Any of you have an Amazon Web Services account? Okay, so if you don't have it, you've never done it, then it's good for you because they give you a year of some free tiers resources that you can try. But if you've already opened it, as long as it's not with more than a year old, then you still probably have access to some very minimal resources. If not, you will have to. I think even if you use small resources, you may have to pay a little bit. It's not much, but it's not tied to email. It's tied to your credit card. Yeah. I mean, you can. Yeah, I mean, it's not needed. I'm just showing you that if you want a virtual machine, either you can use AWS EC2 or VirtualBox, or actually there are many vendors, DigitalOcean, Linode. There are many vendors here. I mean, the ones I mentioned are just a very few that you can use. Okay, but those are just to kind of give you a very realistic setting of having a remote machine. Okay, if you want to have a very minimal example, you don't even have to have a remote machine. You can always run something locally and try, querying it locally. Okay, but that is not exactly as realistic as really deploying something and like querying it. So for example, but if you do deploy something on EC2 and Google Cloud or anywhere else, there are some security and safety things that I'll mention later that you should do, so that you don't like there are I would say some organizations or people who keep scanning for which service is unsecure and may query it for like trying to see if it has some vulnerabilities and stuff like that. So you want to kind of avoid such things. There are some extra steps you need to make. Okay. There's some information in the notes that's there in our repository. So in the MLOps notebooks repository, there chapter-wise there's some notes. There are some comments about how to secure things. But as I said, our source of truth actually always has to be the tools, the tool documentations. Yeah. So the second tool is SSH. This is just in case you do have a remote machine, then SSH is a way to kind of securely connect to that remote machine. So the way many of these things work, is that when the client wants to talk to a server, right? Server is think of a machine, really a laptop, literally sitting in AWS's data center if you want. When the client wants to connect to the server, there's obviously, it needs to know what is its address, right? It could be a domain name, or it could be what is called an IP address. Okay. Somehow, if you know that information, there is some internet backend infrastructure, and that's actually very important for worldwide connectivity, right? So there's infrastructure behind the scenes that lets you actually, whatever, let's say you request, hey, give me a prediction for value X. To reach up to your server, there's behind the scenes machine infrastructure or the network infrastructure. Okay, It could go across continents and so on. That's behind the scenes for us. But once it gets to the server, you still have to specify a port, okay? A port from which somebody on the server side is listening on that port. Okay, what is the port? It's like, I think of a door or a window. Somebody has to be on the other side, waiting at the door, waiting for a request to come so that they can actually respond back with a response, right? So generally, like for example, web pages, they're served on port 80 or 8080 or something like that. So those locations, those numbers, in addition to the domain name / IP address, is the location where some program is listening on the server side. Okay? So there could be many port addresses, thousands of port addresses. So you can think of thousands of programs, each one listening at their own port for any activity that they want to do. So SSH, for example, there's actually an SSH server service, which actually is listening at, for example, port 22. Okay, there could be a web page serving service which could be listening at port 80. There could be a Flask service which could be listening at port 5000. Okay, some ports. So you need to specify the port at which you talk to a program on the other end. Okay. So as I said, SSH is something we'll quickly see. Last thing is on the Python side, we'll not see all of these, but we'll at least get Jupyter started and see how to kind of how to expose it to the internet, or if you run Jupyter on a remote machine. On local machine, you may have Anaconda distribution, perhaps maybe you can double click and you get a Jupyter environment. But maybe on the remote machine, you may have to do a couple of extra things so that it's stable and set up. Okay. Actually, I mean, since I'm mentioning Jupyter, there's a managed AWS service called SageMaker, which obviously consumes resources like compute and whatever domain address and so on. But it will exactly give you a Jupyter environment so that you don't have to worry about doing anything, right? So you can just get a Jupyter environment and just focus on your thing, But that makes sense for a data scientist. Here we are just doing a little bit more because we said in the spectrum of things, we are trying to do most of the work ourselves, and then we'll slowly get away from it and do completely serverless, and then we'll try to do something in between, which is the containers. Okay. Here I put in some other names. Pandas I just mentioned, like everybody knows has used it or should use it. Torch is a package for deep learning models to serve as well as kind of define and train, for example. Pickle is a way to serialize. Serialize means if there's a Python object in memory, like a dictionary or a list, or it could be anything else, if you want to write it to disk, okay? If you want to have a dictionary object, you want to write it to disk, it gets serialized to disk. It gets represented as a bunch of bits and bytes on disk so that you can again unpickle it and you can get back the dictionary. Okay? So it's like converting into text essentially and sending it to a hard disk location or some other storage location. Requests, in fact, we'll see, as I said, curl is one example, but requests is another library in the Python standard library. So when you install Python, there are a few libraries that come along with it, like Pandas doesn't come with it, and Jupyter doesn't come with it, but there's some libraries that come with it. And so request is a library with which you can make requests from the client. You can make requests, get requests, for example, and get the resource, or you can make a post request and post and update some information. Finally, Flask is what we'll see as an example for running our server software, machine learning serving software, model serving software. And Poetry is not something that we'll probably not see, but it's just a way to organize your Python code and manage versions and things like that. Okay, maybe we'll see it later. Now there are some commands. Now the last bullet point is completely optional. There are many ways to achieve things, right? Interacting with computers. Okay? There are many user interfaces to computers, right? Operating system, we can use a browser, we can use keyboard, we can use GUI software, which is what most of the times you use it, like to browse or do other things, or when you're using Tableau. But there are what I call CLI, right? Command line interface commands. Okay, CLI commands are things that you might have also tried. Like on MacBook, there's a terminal app. On Windows, you have the shell, PowerShell, and on Linux you have the shell as well. So you could try some commands, and so we will see. I mean, at least I will do it this way, but it's completely optional. obviously, there are many ways to achieve the same thing, but sometimes, or at least historically in the industry, people are a little bit more used to using command line tools or just simple utilities to kind of navigate around things, but it doesn't have to be that, right? So actually, more and more things are becoming getting abstracted out. So you actually write things in expressive languages like Python or other domain specific languages. So you don't have to do things at the command line level, but these are things, utilities that are available on your laptops, especially Windows or Mac or Linux. So you can learn a little bit about. Okay. So although I will not explain each one of them here, but if I use it and if it seems alien, then I will let you know what I'm doing. Okay. So these are tools, but really our objective is just this: just start a Python environment and run start a Jupyter session and just start Flask at least locally, and then we can worry about web server and stuff. Okay? And yeah, and I'll kind of stop there. And I mean, stop in terms of like lecturing part, and then we can ad hoc figure out like next steps to do. So let me do at least that part. So this is the this is my terminal. But I mean, you guys will also have something similar. So what I'm going to do is many times, at least on Linux, I already have Python installed. Okay, even in Mac, actually it comes with Python installed. So the way I'm going to do it is there are many ways to do the same thing. I keep saying this again and again. I'm just going to create a virtual environment. Okay, you can do it with Anaconda or Conda command line command as well. But I'm just going to do it with VN package. Okay, so VN is a package, and I can give the name for the virtual environment I'm creating any name, but I'm just going to use the same name as. I'm just going to use the same name just so that I know that it's a virtual environment. But you can give any name there. Okay, the last argument. -m means module. Okay, so if I do this. So let me actually show you. So there's nothing in this folder. ls is like listing whatever is in the folder. Actually, ls minus list all, la just means list all. As you can see, there's literally no hidden files or anything like that. So many times there's sometimes hidden files, and you'll see Git, the version control technology, it keeps a hidden folder within which it tracks your versions. Okay. So what are we doing here? Ideally, you should be doing this on the server side. So no, if you're just running Jupyter, it's okay if you do it on our side. Some point of time, on the server side, okay, we also want to start our Flask machine learning prediction service. And so they also need, on that side, we need a Python environment, okay? Instead of installing Python packages throughout the operating system, you can restrict your installation to just your, just your project, so that you can multiple projects could have different dependencies and they're not interacting with each other. Okay, so let me just run this. So after run this, I have a virtual environment. Okay, some folder. So actually, let me not see into it. But if you look at, you can see there's some bunch of files in there and folders in there. We'll not worry about them. So we'll just for this particular module, this is how you do it. There are other modules and other ways to create virtual environment. So I need to enable it. Okay, I created an environment. I need to enable it, and then I'll start installing things so that the installations are only restricted to that virtual environment. Okay, that's the purpose here. Okay, now virtual environments for Python are different from virtual machines that we're talking about. Just to kind of put that out there. So source, folder name, whichever folder that's there in the current directory. And then for this particular way of doing things, there's a file called activate that I need to source. Okay, what is source? Source is again a utility that's available in both Mac and Linux natively. I'm running, by the way, just Ubuntu. This is one type of Python distribution. So source is just a way to kind of execute each line in that file. Okay, we don't really care about what's there in the file. It just ensures that all my Python is, it just changes the environmental variables so that whatever I install, if I do pip install XYZ, is only related to the virtual environment. Okay? So sourcing is just a way to kind of update your environment variables in some sense, if you want to think of it that way. There's more, but that's essentially what's going on. Okay, so once I did source of that folder /bin/activate, which is specific to in my way to create a virtual environment, you can see that it says v and v in the front of my prompt. Okay, that's just a way for that program to tell me that, hey, now you're in a virtual environment. Different programs will do it in a different way. Anaconda will do it in a different way. Sometimes you don't even need this command line way of doing it. You can actually do it via UI, create virtual environments. Okay, so virtual environments is a good practice as a programmer. I mean, obviously, as a beginner, you don't need virtual environments. You can install lots of packages in the same default Python distribution. That's fine. But as you mature, it's better to kind of restrict your stuff to different projects and code bases. Okay, so now virtual environment is there. So, so if I, for example, if I type which Python, it says this is the Python installation. Now, okay, this is saying it's in your virtual environment. You can see the v folder there. So that's my folder there. So now I can just install. I can just do pip install. I mean, there are a few more things you can do, but I'm just doing the basic stuff. Pip install. Jupyter lab. Let me just install Jupyter lab so that I can at least start the Jupyter lab and I have a running Python environment. So I think I ran this command earlier. So it's using some cached data. Cache means a copy of some data that was fetched before, but there is a copy of it locally, temporarily, in case it needs to be used. Okay. If there's no cache, it'll keep, hit some third-party servers, ask for, hey, give me this package. That server is going to give you that package, and then it's going to install it. So there's exactly the same ideas that we saw, right? So the clients is going to ask for some server, give me all these Python packages so I can install it. Right. So it says it's installed. So I can run Jupyter Lab. So this is the way to quickly run Jupyter Lab. If you run it this way, you will get a kind of a secure link, and it's only going to be available. So it's only going to be available to you locally. So it's not going to be like if somebody else had access to your IP address, and they'll not be able to go to that 8888, which is the default port for Jupyter Lab. They'll not be able to connect to it, even if they had a connection to your machine. Okay, but how do you change that? You can specify, right, --IP. If you have a public IP address, you can specify the IP address here, like something like that. You can also specify the port. If you don't like the port 8888 and you want to use something else, you can specify. These are just called command line arguments. You don't have to give the arguments this way. We are doing something manually and interactively, but these are ways to kind of and then if you're going to serve Jupyter from, let's say, an EC2 machine, some remote machine on AWS or DigitalOcean or something like that, you also don't want, so if I run Jupyter Lab now, it will try to open a browser tab or a browser window automatically. Okay? If you don't want it to do that, so you can put an extra command called no browser. Okay? So if you do this, let me drop the IP part. But if you do this, right, so at least it did not automatically try to open a tab. Otherwise, it would have opened a tab right there. It'll say, hey, here's how you will, if you click on this, then you'll get to that. This extra stuff that you see, a lot of, some alphanumeric things, because it wants to keep it secure. Okay. You can also make the Jupyter Lab instance, especially if you're running it from somewhere else, secure by giving a username password. You can actually not username password, but just password, okay, at least at the minimum. You can also restrict. So whenever you have a remote machine, as I said, remember it's a remote machine. In remote machine, you're running Jupyter Lab. It's a software. It's listening to some port on that remote machine, 8888. You can make it listen to only some IP. Listen to on that port. Listen to only some incoming requests and not other requests. What do you mean by that? you can actually specify when you're running that program, hey, only IP address 1234 can connect to you. Like, for example, if my IP address, I always know that it's always going to be 1234. That's not realistic, but if that's the case, then on the server side, to keep it super secure, you can say, hey, unless 1234 is the only IP, is the IP that's asking for me to serve this Jupyter Lab interface, I'm not going to respond. That's like super secure, because that's nobody else can actually even open that page. Okay, so you can do that, for example, using what are called security rules in AWS, but there are many ways to do it. Okay? But let me not do all that. So let me just go to this. Okay, so this is all fine. Just close this stuff. Okay, so I just wanted to open this because now I can do that last example I was talking about. But here, okay, let's actually we can now start using the terminal here instead of like two terminals. So we have this terminal. Let's actually, yeah. So as I said, there's only one file here, venv, the same file that from which we started we create the virtual environment, pip install something, and start the Jupyter session. It's the same folder. Now, as I said, there's this program that I mentioned, curl. So I just want to show you, like, so this is my website, but then you can put google.com if you want. So curl URL on the command line is by default will do a get request. Get me, tell me what's there at this URL, which is a resource location, right? So, so saying, okay, I have so it just gave me a wall of text, because remember HTTP is text protocol, and I got basically the web page code, right? The HTML, CSS, and whatever JavaScript from my website, right? You can do the same. I just want to show you this because we're going to do this for when we query our machine learning prediction service. So we can do the same thing by importing requests. I don't know if it's installed, or I think I said, okay. So request is in the standard library. So we have requests, so we can ask for so we can ask the same question, or I mean, I'm doing it this get operation. I want that URL, right? So so actually we can look at, there are many fields in the in this response object. You can, so but that text, wall of text that we saw in the command line side, using that utility, now we're connecting via this programmatically via a package, right? Via a request library, right? We're still seeing text, the same text from my website, but this gives you a sense of how does the clients make requests. Okay, you can make requests through command line, you can make requests through programs, you can make requests through browser. If in fact, if I make requests through browser, obviously it'll show up my web page in a nice way, because the browser gets this wall of text, but also interprets and packages nicely so that it looks like a web page, right? So that's something that web browser does, which we don't do. Okay. Generally, when requests succeed, the server also says, hey, here's the thing that you want. I actually have it. Here's a web page, and I'll say 200. The server says 200, so that I know that, okay, things succeeded. Okay. If you ask for a request which the server doesn't have, then it will say, 404. Okay, you might have seen this 404 pages on the browsers, right? Yeah. And so there are many codes for client and server to understand. In addition to, they'll talk to each other through these HTTP verbs, get, post, update, and so on. But these codes are also, status codes are also let the clients and servers understand whether something succeeded or something failed, and so on. Okay. Actions, but also feedback on like what happened. In addition to obviously getting back the resource that you wanted. Obviously, if you don't get the resource that you wanted, you might have done something wrong, but you get these responses. Like, for example, if something you don't have access to, you'll get a 403, which is access forbidden or something like that, right? Okay, so we just saw a couple of ways to do this, and maybe in the future we'll see other ways. There's a tool, professional software developers use a tool called Postman, for example. I mean, many other things, but that makes making these types of requests easy and helps you kind of, I guess, test your API, which is what we're trying to move towards. Okay, our prediction service is a essentially an API endpoint. Okay, what is an API? Application Program Interface. It's just a contract of how you're going to interact with some service on the server side. In our case, it's going to be prediction service. Okay, so let's now come back to any questions here. Yeah, it's the same. It's just a text, huge wall of text. I just did not give extra parameters, but oh, curl, you have to post process it. Curl is just doing the fetch operation. Then you'll have to do extra slicing and dicing through other programs. But it's a programmatic command line way of just accessing URLs or downloading things and so on. Here, the response, so curl's equivalent would be response.text, right? So, which I just showed earlier. This would be exactly the thing that the curl is also showing. Okay. But response object has more things like status code and and I don't know if there's JSON, but I don't think there is anything JSON here. Yeah, that's not the right way to do it. Okay, I mean, a response object has many other things that you can find it handy. So with curl, you have to do a lot more things to kind of slice and dice or do anything more with your, because it's not a programming interface, right? It's actually already a executable. It's like a single executable doing fetching operation. After that, how do you interact with the fetch thing? You'll have to figure out. So, like you can do. So I like this perpendicular symbol that you see here, or whatever the vertical bar you see here, is called a piping operation, which gives that output from the previous command to the next command that I'm going to execute. Like I can do what is called a grep operation. Grep means search for something. Okay, I can search for, hey, does this include the word Teja, right? It says, okay, Teja appeared here, here, I know, like 5 times, right? So this is one way to kind of actually work with the curl's output. All these are available on Mac or, these are all, so I'm showing you one optional way to kind of, these are Unix commands. Yeah, but you don't need the grep stuff and all that. I just showed curl as a way to fetch things. So I was just showing you the client, right? So here, I did use the word curl. That's why I showed curl. You can either do curl or you can do requests. Obviously, you can get the same web page from browser, and it actually is beautiful because browser does the post processing and shows the web page in a nice way. But programmatic, if you do it, that's the raw information to get. Okay. Okay, let's come back here. So what I want to do next is run a Flask service. Okay, that's I know I'm running massively over time, but at least in the demo. But what I want to do is do it in a 2-step process. First, I'm going to do a clone of my repository, and then I'm going to go into that directory, which has the Flask example, and I'm just going to run it. Okay. Now, what is the 2-step? What is the first step, right? When I said clone of my repository, the code or code examples are in this URL, right? So if you do a get or a request, you will actually get a huge amount of text, which is essentially corresponds to this. Okay, browser is interpreting and nicely showing it here. Now, for those who have, how many of you have never used Git before? Git or GitHub, it's the same thing. It's not the same thing, but GitHub is a vendor and Git is the actual software technology. But how many of you have used Git or GitHub? Okay, have used. Yeah, have not used. Okay, 3, just 4 people, 5, 6, 5. Okay, so this vendor here, GitHub, is a service or whatever property of Microsoft, and it basically lets you what they call as social coding, right? Then you can collaborate, you can help each other with improve each other's codes or collaborate and create interesting projects, open source or closed source and so on. But behind the scenes, the bare bones, one of the bare bones technologies, GitHub obviously does a lot more now, but one of the bare bones technology is a program called Git. Okay, and Git was created, several years ago, almost a couple of decades ago, perhaps, for the purpose of version controlling your code. Just like if you use Google Sheets or even Microsoft Word, there is history of your edits, right? So similarly for code, this makes sense, it's all textual, so it makes sense to have snapshots of your code, so that there's one working code and new feature being developed doesn't get mixed up. If a working code is deployed, let the working code be deployed while you work on a feature, like maybe adding some extra features. Yeah. So anyway, Git we'll talk about later. Although in the slide, there is a slide in the first lecture itself which talks about Git as like a quick slide thing, but we'll do that later. What I want to do is two-step process, as I said. I want to just clone this repository. So each folder, so generally GitHub, for example, each github.com, after that is the username of a user who has an account with the service. And then you have the repository name. Okay? That's the repository name. It's just a folder name, basically. What I'm going to do is, what you guys can do, if you just want to explore the code, you can always go and say download zip, and you'll get a zip snapshot of whatever is currently in that code. Okay, but what I want to do is actually run this command. If this doesn't work, I'll just do a zip. But basically, it's a way to copy all the files, basically kind of make a mirror of whatever was there on that on this website. Okay, and this website is not on my local folder, but I want to copy on my local folder because I have a local Jupyter running. I want to open that, open some programs, and try to run them. Okay, that's the first step. Get the copy. Second step, actually run our service. Okay. Okay, so let's say it's here. So the way I do it, and you can do, again, there are many ways to do every step. I'm sorry for repeating this again and again, but I'm just going to do it via command line. But there are actually, GitHub itself has a GitHub desktop app through which you can do cloning. You can copy things and so on. Okay. But there are also other third-party software that you can use to do the same steps. So I'm just going to do git clone, git space clone. Clone is the action that we want to do, and the program supports that action, understands that action, and this is the URL. It's quite small. Yeah. So git clone and some URL that I got from that website, right? So I got that. So now you can see that there is that extra folder. So untitled .notebook, just because I created a notebook, there's one notebook there. And now we have this folder called MLOps -code-examples. Okay. That folder or that code base has a lot of issues. I will not focus on the issues now, but I will get to it. As I said, if you want to kind of make better contributions, for example, that folder doesn't have a requirements.txt. What is the requirements.txt? It at least specifies what supporting packages are needed to run the program, right? So it doesn't have it. But let's like if you double click from the interface, you can see there are many examples. But actually, let me do it. Okay, so these are all the names of the examples here. So we'll just start with regression. Okay, so that's Flask example. So Flask _example are the examples related to serving this batch model examples that we're talking about. Okay, so let's it's somewhere in between, but the one I highlighted here, Flask example regression, is what we want to try it out now. Okay. CD is a command to change directory into that folder. I think I forgot to mention it. And by the way, if you're lost any step, I want to finish it quickly so that if you have any issues, I can come over and we can discuss it. And that's the lab component. You try out, and if you think this is easy, try out a harder one. Okay, there are other Flask examples which need more thinking or more effort, right? So if you see, there are actually a couple of folders here. Sorry, one folder and one file here. Actually, let's open that file that's there. It's a Py file, and you can see what it's trying to do. And so I want to explain how something about the server, something about the program that we're running on the server, in particular the Flask-based program. How does it work actually? Okay. So Flask, what does Flask do and what its role is the following, right? So we have a model, and the model has some. What is a machine learning model? It's a bunch of parameters that can take an input and produce an output, right? So here is an example. So we want to kind of serve the model, serve in the sense that the model needs to kind of be ready. If it's given an input feature vector, it needs to respond back saying, hey, here's the output. Okay? That's what the program has to do. That's what it has to do. So for us, that all that functionality is captured in this function here called predict. Okay, this is a very normal Python function, but with some extra things, and that's what we want to focus on. What is it doing? So predict function by default gets an input called request. Okay, how is it getting an extra input? It's because of what is called a function decorator. Okay, so decorators in Python are some feature that if you've never encountered it before, think of it this way: that extra line on the top at line 18, what it's doing is in your code, it sees what is the function that's defined right below it, and it adds some extra bells and whistles. Okay, it's like wrapping that function around. It's like creating a cover on top of it to do some extra stuff. Okay. In fact, that is actually the key thing about this Flask package. Okay, what is the Flask package doing? What is Flask web app doing? Is that when you run this program, it continues to run. And as you can see in the name here, it's saying if somebody hits, so it's going to continuously run at whatever IP address. It could be the local IP address or local host, people call it, or some IP address, public IP address. Whenever there's a request at this location, / location means the default location, like www.google.com/. Okay. At that location, if somebody asks for a get me something from there, then you execute this function. Okay. If somebody is hitting this location, execute this function. That's the, in the simplest way, that's the role of this extra package called Flask. Okay, that name you can see here. Okay, and the other two things we will see in a second. Okay, so now let me linearly go through this code. Okay, so there are some imports. I don't think. So, okay, we don't even need pickle here. Okay, we don't need pickle. So we just need Flask to create that extra glue so that when so Flask is the one which runs this service, machine learning prediction service on the server side, so that when somebody reaches this location, it'll run this function. And when this function is run, it'll say, oh, is X in my input? Think of X as a feature vector, is an input. If it is there, then it's just asking, okay, your input was X, and my prediction is going to be model, which is a model that I have here, with that X as an input. Okay, so I'm just doing some type conversion. I'm just making a float because X by default will be some string, and so instead of that, I'm making a float. Okay, so now let me actually tell you what the model is, because here it's a very kind of easy to understand model. It's just a regression model. Okay? It's a regression with a slope and an intercept. Okay, it's just one-dimensional regression with a slope and intercept. How do I see that? You can see it here, right? So it's a D is the slope and A is the intercept. I could have used other names perhaps. Or actually, I can actually even get rid of all this. Okay. Def model, take a value X. and then return. I mean, I can just do 2 times x plus 2. Okay, so let's say this is my model. Let me actually get rid of all this code. This is my model. Okay, this you can see this is just a one-dimensional regression, right? Some given input, multiply it with a slope parameter, and then add an intercept. Okay, and you can imagine instead of this model, you can have a random forest model or whatever, a deep learning model. So you have this model, and then nothing else is happening. Everything else is related to the web app. Is here I'm instantiating the app, which you need to look at the documentation to understand, like, this is just a standard instantiation of this Flask utility. And then it's just connecting routes to functions. Okay, that's the basic idea here. And there are many things you can do, login credentials and all that. But here it's just saying, hey, if you hit the main route, then as long as X is in the request arguments, then I can do the prediction. Is that clear, or is there any confusion with this code? This statement JSONify here just wants to return response as a JSON object. Remember, JSON object looks like a dictionary. In fact, you can see that I've actually created a dictionary here. This dictionary has 2 keys and 2 values, right? It has a key input. It's just telling what was the input. It's just responding back by saying, hey, here's the input you gave me, and here's my prediction for you. Okay. The first key is input, and it's telling you what the input was. And the second key is prediction. It's telling you what the value is, what the model's prediction is. Okay. And it's saying there's a try except here, because in case X is not actually a number, I can't convert it to a number, maybe it will fail. And so I have to kind of say, okay, if I mean, this is a very bad way to write it, because you need to catch the exact exceptions and then maybe understand, these are the types of exceptions that happen, and actually tell the client, hey, you try to do this, try to do something else, right? So here, you can actually improve this code and submit a pull request if you want on GitHub for this. But if X is not even in the arguments, if you just try to reach, hey, go to this web, URL, and you never gave X the input feature vector, then you at least have to say, hey, you did not succeed. Success, I guess let me not put success status. Let me say status is false, and the message is input X was not even, was not passed. Forget about passed correctly, right? Yeah. And then if name is main app, this is just very standard, right? You're just calling the app. So this is my function, and let's actually just run this. So where do we need request? Because as I said, request is like a default thing that Flask provides us. Like if you get a request from a client, that request object is available for the function. Okay. Any questions about this in terms of architecture? We can just run it and see, obviously work. If not, we'll fix it. But any questions here? Okay, if not, we'll just run it locally, but locally in the sense that if I think of this as my server, then I can just run it, right? But you can run the same program on EC2 machine. As long as you create the virtual environment and do it, it's a clean way to do it. Okay. So I'm just going to do Python file name.py, in this case, Flask service. And it says something, right? So if you remember, we created a virtual environment. We only installed Jupyter Lab and all the dependencies that needed that kind of Jupyter Lab needed, but we never installed Flask. So we'll have to install Flask as well. So this is where I said that the example doesn't have a requirements or text file, which is something that you might have seen in other packages, for example, other code bases. So here it says, okay, let's see if it needs anything else. Okay, so now we ran this program, right? As you can see, and it says, okay, serving this app Flask simple regression service. And it says debug mode is off, and this is only a development server, and do not use it in production. Okay, that's because this Flask thing is a Python service. It's actually not. It should not be directly exposed to the client. In between, there's something called middleware. Some extra software. It's just extra software, which it's saying use something in between instead. Okay, you can still run it, but don't directly run it. Use that extra software which will run these. In fact, not just run one version of this, it will run multiple processes. Okay, that's all a little bit more involved. So let's not worry about it. Let's just run it this way. So now it says it's running at this location. So let's actually, I don't know. If I just click it, okay. So yeah, I just clicked it, but you can see what it's saying, right? So this is just Firefox's way to display things. If you did the same thing on Chrome, you would get slightly different like representation. But it's just saying input X was not passed, so status is false. Actually, it should say failed, perhaps. We'll change that. Now, remember we did the same curl operation. So we can actually do the same operation again, just to get a feel for like, so if you do curl and this, we'll get that dictionary-like looking thing. It's called a JSON object, okay? And in fact, we can actually parse it. So on curl, you'll get something like this. And we also did requests, right? So we, in fact, let's comment this out. And go to slash. I don't know if slash is needed, but okay, I ran it, and then I don't know if I type the response. Response is 200. It did respond something, but if you look at response, I don't know if JSON works, but yeah, JSON works here because an actual JSON object is returned. Okay? If you just want to look at response.text, it's also, it's exactly it's text with a slash and extra things just to show that it's actually just a text thing. Okay, so we were able to query to some IP address. Now imagine this IP address can be somewhere else, like EC2 machine. When you spin up an EC2 machine, by default, it will get a public IP address. Okay, so you just need to change from 127.0.0.1 to whatever the IP address you can get. And we'll do EC2 stuff maybe next lecture and the lecture later anyway. So maybe I can just show you that aspects later. Okay, just knowing the IP address and stuff. But for now, we know that the service is running, albeit it's running locally in our machine. We were able to interact with it through Python, through command line, okay, through browser as well. I mean, on the browser also we saw that, we can go here. In fact, let's come back here and say, okay, now how do we pass some extra information? We can do slash, okay, that goes to that function, predict function. But the predict function is expecting some argument X, right? So we can put a question mark, X is equal to 10, okay? What happened? We got a different response, okay? Now, what happened is that 22 question mark and then key and value is exactly, the key is going to be the argument present in your request. Okay, so so here the key is X and the value is 10. And so if you go back to our code, it's looking for is the key X in our argument. Okay? If it is, then look at what does the value for that key correspond to. That's our value is 10, but 10 is actually considered a string by default, and so we cast it as a float first, or float or whatever you want to do it, and then we call the model function on it. Okay, and so 22 is the response we got, is because 10 times 2 plus 2 is 22, right? So at least locally, we were able to make a query. We did it through the browser, but we can do this. I mean, that's exactly the same thing that you can do here also, right? So question mark X is equal to, and in fact, you can do so here I can do a this F literal. So I don't know, F string, sorry. I don't know, have any of you used F strings before? F strings are basically a way to kind of substituting a variable value into a string. And so you can define input feature vector, right? Okay, let's actually make it this way. Get the response and then print response dot JSON. Yeah, let's just do this. So this is what we got, right? I'm just giving you some arbitrary inputs, and my web server responded with these are the predictions, right? I mean, it's just doing simple regression, but that's the core idea. Right? The core idea that you want to take away is not any crazy, other things. It's just that the Flask is a simple Python-based utility that's mapping a URL, a location, to a function. Okay, at that location slash, right? At the location slash, it's mapping to the predict function. And then how do you make the get request? Hey, I want a prediction for X. This is how you can do a get request. You can just concatenate it on the URL itself. So anything that follows a slash with anything that follows a question mark is essentially information for, hey, I want this, I want that. Okay. Any questions here? Yeah. Yes, so this is so by default, this is a special IP address that only your machine, it's basically, every machine will have the same IP address if you run Flask like this, because this IP address is for your home, for your actual local machine. Okay. Your public IP address, you can just ask what is my IP and it'll tell you. I mean, on Google or something. That's the public IP address, right? But this is the local IP address. Instead of this, you can also use, let's see, localhost works or not. So localhost is another way to reference, hey, something is running locally, just access it. The 127.0.0.1 is also saying that, hey, something is running locally, only access it locally. Okay? Instead of that, you could do www.mypredictionapp.com. As long as the domain is mapped to that some behind the scenes IP address, there's a network infrastructure which will first say, oh, mypredictionservice.com maps to this IP address. This IP address is in AWS data center. Go to that machine, go to that port here is 5000, and see that actually some service is running and get back a response. Okay. So if I run this, actually, you'll not see a difference, but I'm actually running it because localhost and that number that you saw are the same thing. Yeah, but they're specific to my local machine. Yeah. Any questions? So I'm going to stop the demonstration here because we have vastly exceeded my objective of what time I wanted to finish this at. So there are a lot of bells and whistles, and there are a lot of questions. I see some people like interested in asking some questions. So let me pause here, and if this is easy for some of you, then you should try all the other Flask examples. Okay, some of them actually I can just briefly mention it, but actually let me go to that page, right? So as the names imply, some of the other examples are not related to, like, for example, ImageNet, right? So this example is actually loading a PyTorch model, and PyTorch model means like something like a scikit-learn model. Like if you build a logistic regression model in scikit-learn, you need to have scikit-learn, and you need to have the model saved somewhere so they can read it and then respond back. So it's actually responding back with like if you look at the thing, it's actually yeah, it's actually it needs PyTorch basically. It's using a model called, I guess, DenseNet something, and sorry, it's using DenseNet, ResNet, some model name, pre-trained model, and it's actually taking an image as an input. So download an image of a cat, and then run this program, submit a cat, and it'll get back to you the name of a class it formed. Okay, and you'll find, I mean, ImageNet is a data set where cats have lots of categories or lots of classes, so you can get back a class name. I mean, this is like, I'm just saying that if you think that the previous example is too easy, then you should try to go up with this, because it's like fun things to do. Because at the end of the day, the structure is the same. It's just that there's a port, there's a service, there's a program that should be running at the port, and if it's Flask based, then the Flask there should be a decorator which says, at this location, if you ask a question, this is how I'll respond. Okay? That's the key. And then the actual web server should have obviously Python environment on these packages. So for that, you need a virtual environment and like some installation on that side. So those are activities that you can try to do. Okay. Any questions? There has to be, or okay. So I mean, now onwards, I think you can. We're not breaking, but you can try it. Or you can also take a break. Obviously, you can try the example, at least at the minimum, the example that I showed, just so that if you are not comfortable with much of this, then this is a good time to kind of try it. And people who are obviously, are more comfortable with this, try the other examples in the folder, in our course folder. Okay. But the goals, as I said, the lecture goals were several things. We did set up a Python environment. We didn't really look at SSH tunneling because I decided not to kind of bring in the complexity of spinning up a web machine on the other side, as in like from AWS or something. We'll do that next time or the next time after that, because we will need to use the serverless service later. We did not secure a web server. Securing is, already if you use SSH, that means you don't, securing a server means you don't let people, like if people come and say, hey, port 80, give me your web page, you'll not even respond. Okay, that's kind of securing, right? Even if you have some service running, unless it's in a secure, like unless you know who the party is and things like that, you don't respond. So that's something that's important in today's world with adversaries and so on. And we did the last one, which is just serve a simple regression model, but you can replace it with anything else. Any scikit-learn model that you built in 572 or 575 or anywhere else, as long as you can get the right imports, save the load the saved model, you can just serve it like this. The challenge is, how do you send a GET request? Like I only showed a one-dimensional example. If you had a vector, right? If you had a vector of features, right? Some categorical, some numerical, you had all of that. How do you send it? You can actually do x is equal to 10 and ampersand y, x2 is equal to 5 and x3 is equal to, you can actually spread it out. That's one way to do it. But other ways to do it is to attach a JSON object along with the GET request. Okay, there are a few ways to do that. So anyway, let me kind of stop the presentation at the moment with that. And yeah, and I'm here to kind of, if you're stuck with any other previous step that you saw and you're not able to make progress, you can call me and I can help you out, but you should try it out. I mean, that's the point of this time. So yeah.